In this lesson, we will be learning an introduction to organic chemistry. Organic chemistry is the study of carbon compounds. The two largest sources of organic compounds are crude oil and coal. The different fractions of crude oil can be separated by the process of fractional distillation, which makes use of the difference in the boiling points of the various fractions. The fractions in crude oil are mainly hydrocarbons, which find immense uses in our day to day lives. The uses include the manufacture of dyes, pesticides, soaps, explosives, cosmetics, synthetic scents, and flavorings, to name a few. Carbon is an interesting element found in the second period and group 4 in the periodic table. An atom of carbon has an atomic number 6 and mass number 12. So, it has 6 protons, 6 electrons and 6 neutrons. The electronic configuration is 2,4 and it has a valency of 4. Carbon has the ability to form long chains, and this property is known as catenation. It can also form rings with other atoms attached to it. The chains can be a continuous straight chain or a branch chain or a ring. Carbon has the ability to form single bonds with other carbon atoms and hydrogen atoms in a hydrocarbon, and such compounds are called saturated compounds. If there is a presence of a double bond between two carbon atoms or a triple bond between two carbon atoms in a compound of hydrocarbon, then those compounds are called unsaturated hydrocarbons. Let's make the structure of methane the first member of the alkane functional group. This is the carbon atom and these are the hydrogen atoms. So I will show the bonding of carbon with the hydrogen atoms in methane. So one carbon atom is bonded by single covalent bonds to 4 hydrogen atoms in methane. Hydrocarbons can also form in other compounds which contains double bonds, as in ethene, the first member of the alkene family. Here there is a double bond between carbon atoms and single bonds between carbon and hydrogen atoms. So this is an example of a double bonded carbon compound or hydrocarbon. There is also an example of a triple covalent bond between two carbon atoms and single covalent between carbon and hydrogen. This is a structure of ethyne, or commonly known as acetylene, the first member of the functional group alkynes. So you will see that carbon can form single covalent bonds as in methane, double covalent bonds as in ethene, and triple covalent bonds as in ethyne or acetylene. Carbon can form continuous straight chains. Here is an example of a straight chain compound of carbon where you have 4 carbon atoms in one continuous chain, and this compound is called butane. Carbon can also form branch chains, as in this example. Here you have a continuous straight chain of 3 carbon atoms, and there is a methyl substituent here attached to the second carbon atom, so it is a branch chain hydrocarbon. Carbon can also form rings. This is an example of cyclohexane. The molecular formula is C6H12. There are 6 carbon atoms bonded to 12 hydrogen atoms in a cyclic structure. Carbon can also form aromatic compounds, and here is the example of a benzene ring with the molecular formula C6H6. There is alternate double and single bonds between the 6 carbon atoms and single bonds between carbon and hydrogen. Benzene is a starting compound for the aromatic chemistry compounds.